Entanglement is one of the most fascinating phenomena in quantum physics and one of the keys to quantum computing's power. It allows qubits to exhibit correlations that defy classical reasoning, enabling them to work together in ways that classical systems cannot. So, what exactly is entanglement? Once qubits become entangled, they no longer act as separate entities. Instead, they form a single, interconnected system where the state of one qubit directly influences the state of others, regardless of the distance between them. To describe this system, you must consider the entire group of qubits as a whole, rather than individually. To illustrate this, imagine two dice that are entangled. If you roll one of these dice at the North Pole and you get a 5, you instantly know that the die at the South Pole will also show a 5, even without rolling it or observing it. While this might seem impossible in the classical world, it's a real phenomenon in the quantum world. In quantum computing, entanglement allows for faster, more efficient problem solving by linking qubits in ways that amplify computational power. This interconnection is crucial for many quantum algorithms, enabling quantum computers to tackle problems that classical computers find impossible.